Okay, so let's real quickly go over this handshake problem again. If you were gone from class today, or if you just weren't quite getting this whole thing when we were talking about it, I'll try to make sure that I've explained every little detail of this thing. So the problem here is 30 people are at a party, and everyone shakes everyone else's hand, and how many handshakes are there total? So at first glance, that seems like a really complicated problem, and it is, but one of the first things that I really want you thinking about with a problem like this is how can I make this problem simpler to start off with? 30 people is a lot. There's really no way you're going to be able to do this. So, in other words, can we make it simpler? One of the easiest ways to make a problem like this simpler is to simply make less people. If this was a party with 2 people, for example, it's pretty obvious. 2 people can shake hands one time. And so if we can make it simpler and look for a pattern, that's going to be the key to this problem. So, first of all, if we start off with just one person, how many handshakes can we have? Well, in this case, we can't have any. There's nobody else to shake hands with. And so I'm going to go ahead and keep a table over here. And so with one person at my party, we have 0 handshakes. Now, if I go back over here, 2 people, I'm going to go ahead and represent the people with dots and the handshakes with lines. So in this case, 2 people, 1 handshake. So far, so good. Next up, we've got 3 people. And if I look at the handshakes that they can have, there's a total of 3 of them. And so 3 people, 3 handshakes. I think we can do 4, no problem here. So if we have 4 people, I'll lay them out like a square here. Well, we can shake hands 1, 2, 3, 4, 5, and 6 times. I think I've got everybody. So 4 people are 6 handshakes. And I'm going to shoot for 5 here. I think I can get into 5. 1, 2, 3, 4, and 5. And so if I look at this, 1, 2, 3, 4, 5, but then I can go 6, 7, 8, 9, and I think there's one more in there. Yep, 10. So I get a total of 10 handshakes with 5 people. Now, if you remember what we were doing last week, we were looking for a pattern here, and we noticed that if the common difference was the same, that it was just a linear pattern like it was from Algebra 1. But the problem is here I go +1, +2, +3, +4. And if you remember, that's going to tell us that this is actually a quadratic pattern. It's going to have like an n squared. And so getting out to 30 is going to be, rather tricky. It's going to be quite a big number. And so here's where the strategy comes in today with the pictures. If we can use the pictures to help us out rather than just the numbers. And so I'm going to try to get this whole picture here, move it up there, just rearrange a little bit. I want to look for some common features in these pictures that can help me out. And that's what we talked about in class. So 1, 2, 3, 4, and 5. So the key thing with this particular problem with the pictures is to take a look at how this term number relates to the picture. And so one thing that I noticed, in the first term, there's 1 person. In the second term, there's 2 people. In the third term, there's 3 people. In the fourth term, there's 5 people. And in the fifth term, there's 5 people. So in any general term, in the nth term, I know there's going to be n people. In other words, in the 30th term, there will be 30 people. Seems pretty obvious, but something to notice here. Now the next thing I want to notice is how many handshakes each person has. I'll do that in blue. So in the first term, each person, the only person, has no handshakes. In the second term, each person has 1 handshake. If you look here, this person has 1 handshake, this person has 1 handshake. In the third group, each person has 2 handshakes. In the fourth group, each person has 3 handshakes. And in the fifth group, each person has 4 handshakes. They each shake with all the other people in the class. So in the nth term, we have n people, and in the 30th term, we have 30 people, but it's always 1 less than that for the number of handshakes. So in the 39th term, we have 29 shakes per person. And in the nth term, we'd say that's n minus 1 shakes each. Now, if we have 30 people and 29 shakes, it seems like a pretty simple, straightforward thing to do to multiply those two together and say, well, there has to have been 870 handshakes then. But before we do that, let's go ahead and think about this. In this fifth one, for example, we have 5 people, and each of them shakes hands 4 times, so why isn't that 20 handshakes? Clearly there's only 10 there. We counted them earlier. In the same thing with the 4 people. There are 4 people. Each of them has 3 handshakes. So why is that 12 instead of the 6 that we counted? And that has to do with the fact that each line representing a handshake is shared between 2 people. This person could count as a handshake, this person could count as a handshake, but it was really only 1 handshake total. And so to fix that problem, what we need to do is divide each of these by 2. Because each person would be counting that handshake, and we don't want to count each one twice. And so you'll notice by dividing by 2, we'd get 6 handshakes here, we'd get 10 handshakes here, and that's our correct number. So for 30 people, what we'd want to do is take 30 people times 29 handshakes each, but divide it by 2. And in that case, I'm not going to get 870, I'm going to get 435. If I wanted to write the rule now, I could do the exact same thing. N people, n minus 1 handshakes each, but I need to divide by 2 because each of those is going to get counted twice if I do it that way. And that lets me do this rule for any amount of people I want. If I want to know for 100 people at a party, I could just plug it into my formula. 100 times 99 divided by 2. And calculator says, oops, hit the wrong button on my calculator. Calculator says 4,950 handshakes when I do that. And so that's what we talked about yesterday. We'll do a few more of these examples tomorrow that are a little bit more straightforward than this, but the key to these all is, can I take my term number and relate it to the picture in some way? In this case, term number matched up with the number of people, the vertices in this picture, and then it was one more, the number of line segments was 1 less than the term number. And that helped me write my rule. The other thing is, try a big number. We're going to be looking for patterns here. Try a big number and see if you can make that pattern hold up and work for the bigger number before you try to write the rule.